Hi everyone and welcome to Miss B Maths Teacher channel. Today or this morning I'm gonna talk about simplifying trigonometric expressions. And how we're gonna do that? It's pretty much the algebra of trigonometry is identical to the algebra of real numbers. For example, if I have this here 3 cos of theta plus 4 cos of theta. So we have like 3 cos of theta, which is like, collecting like terms. They are exactly the same. And we have 3 of cos, and on top of that we have 4 of cos. So therefore, altogether we have 7 cos of theta. So just, the same as algebra of real numbers. So one more example with this one, 3 sine of theta take away 2 sine of theta is equal to, now we have 3 of sine of theta, take away 2 of the same, so therefore it's just going to be 1 sine of theta. So to simplify more complex trigonometric expressions in sine and cosine, so often we use something that you have seen before. So sine square root theta plus cos square root theta is equal to 1. So this one you can replace sine to the power of 2 theta plus cos to the power of 2 theta with 1, or if you have 1 and you need sin and cos, so it can be replaced with the left hand side. So it does go both ways. From this one, what we can actually calculate is just sine to the power of theta is equal to 1 take away cos to the power of theta. And again, it does go both ways, okay? Depends what we need. And then for cos to the power of theta, it's going to be 1 take away sine to the power of theta. And again, same. It goes both ways. Now, let's have a look at another example where we're going to simplify 2 take away 2 cos to the power of 2 theta. So now, same as in algebra of real numbers. So we're gonna look for common factors. This case we can see that 2 is common for both terms. So 2 is going to be taken out, and we will be left with 1. So 1 is left here. Take away cos to the power of 2 theta. So we have seen just before that 1 take away cos to the power of theta, this expression here, is actually the same as sin to the power of 2 theta. So, and that would be our answer. Let's have a look at another one. So if we have sine to the power of theta cosine theta plus cosine to the power of 3 theta. Again, the same thing. We're looking for, if you want to simplify, we're looking if you do have anything common factors. So we can see that both terms have cos theta. This one actually has 3, but this side has only 1. So cos theta is common. So here we are left with sin to the power of theta plus, we took 1 out from here, so we are left with 2 cos to the power of 2 theta, then equal to, and we're looking, can we simplify this even, further? So sine to the power of 2 theta plus cosine to the power of 2 theta can be replaced by 1, so it's going to be times 1. So, and our answer is cosine theta. So pretty much, as simple as that. Now, sometimes we have to expand, so, and let's have a look at this one here. Cos theta take away sine theta, and then everything to the power of 2. Now, You have seen a perfect square before, so we're going to use the same rule. I'm just going to put here on this side, let me use, blue. So perfect square, a plus b to the power of 2 is a to the power of 2 plus 2ab plus b to the power of 2. I feel like singing. So if you have takeaway here, so you're going to have takeaway there, which we do have. We do have takeaway there. So let's apply this rule, perfect square rule. So the first one for us is cos. So it's cos to the power of theta. Take away 2 times cos theta, sine theta, and plus sine to the power of 2 theta. Now what we can do here, so we can actually combine or put next to each other. So cos to the power of 2 theta and sine of to the power of 2 theta. So together, that's going to be 1. So this can be replaced by 1. Take away 2 cos theta and then sine theta. And voila, that would be our answer for this question. Okay, let's do maybe one more. Let's have a look at the next one. So, what do I have? So, do I have an example? Okay, let's have a look at this one here. Cos to the power of 2, let's use alpha now, okay? So, just, another angle. Sine to the power of 2 alpha. Now, maybe this looks familiar. So, pretty much, this is something called the difference of 2 squares, which I'm going to put through here. A to the power of 2 take away b to the power of 2 is equal to a take away b, oopsies, brackets, and a plus b. Okay, we're going to use that one. So equal to, okay, let's have it here. Now, this is the difference of 2 squares. So difference is this negative sign. So that's negative difference between 2 squares. One square, another square. Okay, so let's do it. Cos of alpha, cosine of alpha, take away sine of alpha, then multiply cosine of alpha, and then plus of sine of alpha. So this one is, just expanding. So now if you're gonna, do like apply the foil or something like that, you're gonna end up, with the same thing that we started. So it's just expansion. We're just practicing how to expand. Let's have another one. So the next one, again, we're gonna factorize, simplify. We're gonna see what we're gonna do. So 2 take away 2 cos to the power of 2 theta over 1 plus cos theta. So first thing, we do want to simplify at this stage. We can't see anything. Let's have a look if we can factorize. So yes, 2 is common. We're going to be left with 1 take away cos to the power of 2 theta over 1 plus cos of theta. Now, this expression here, this one here, so that's the same as 1 to the power of 2 take away cos to the power of 2. So, which means it is actually the difference of 2 squares. So what we can do, it's 1 take away cos to the power of theta times 1 plus cos to the power of theta. Please note that the order, if you're going to have first 1 take away cos to the power of theta or 1 plus cos to the power of 2 theta, it doesn't make any difference. So now we're looking, can we cancel? Now what's happening here, so this is actually gone. So it's the difference of 2 squares. Yep. So, yeah. Let's see, I'm just going to rewrite this a little bit nicer. Okay. So cos of theta. Can we cancel out? Yes, we can. We can cancel out this one and that one. So we're going to be left with 1 open the brackets, 1 take away cos theta. So that would be all for now. On top of using this simple formula, so we do have something called additional formulas, and they are called angle sum and difference identities formula, and then we do have double angle identities. So and I'm gonna record some questions with the other formulas in different video. Thank you very much for watching, and I'll see you soon. Bye.